Yeah, this is Toprak. Thank you so much for calling me and Numberly for this organization. So I'm working as a data scientist at Numberly, mainly working on Gen AI and traditional AI solutions. I started to work as a software engineer, now AI. So the mic is yours.
Okay, and I'm Eric Debeir. I'm the CTO of Datalchemy, and we are going to talk to you today about, and it's a not so funny subject, open source with large language model. So I'm going to share my screen. It will be it's a common presentation between Toprak and I, between Numberly and Datalchemy. And we really hope you enjoyed this webinar. If you got any question, any criticism, please feel free to give them. And as I was saying it a bit before, if you got questions, but there is confidentiality in the subject, obviously you can send emails to both Toprak and I, and we'll be very happy to answer you. So, open source large language model, a very interesting subject. But first, quickly, quick presentation of both actors. So Datalchemy, we are a consulting firm. We are working on a lot of different subjects, medical imaging, document data extraction. We are working for a lot of different clients. You got them on the right, from generics healthcare to the aviation directions. We are working for some state organizations too. And please feel free to come to our website. You will find more or less once a month some what we call Écho de la Recherche. So we are actively looking at new papers in order to have a better understanding of how the AI field can evolve, and we are trying to give our insights into this research, which is a huge part of our activity. And Toprak.
Thanks. So Numberly is an international company on the marketing and CRM. So we help the brands for the campaign management. We have 4 main focus, which are CRM and data. We provide a MarTech platform for the campaign management. We also help for digital media. And in addition, we give some consultancy on the strategy and the insights. We have multiple AI solutions that can touch to many steps of the campaign management to improve the performance. And for the company, we have more than 500 employees, the base on Paris, 8 offices, and we operate more than 50 countries. For the clients, BNP Paribas, L'Oréal, HSBC, Danone, and more, I would say.
And so, back to the subject. So today we want to talk about something we read a lot, we see a lot on the internet, open source large language model. And when we see this information, we want to trust it, because open source is something, reassuring. We're going to talk about that. However, where these words, open source, does not have the same meaning for large language model that it could have for classical software. And in order to understand why there is such a difference, we have first to make a quick reminder about the limits of large language model. We use these tools a lot, but they are very recent tools. The academic paper that created these tools are quite recent, and so we're still a bit blind about the limits of these tools. There are some very important shortcomings that we have to be aware of when we are working with large language models. These models are, as every deep learning model, are black boxes. We are still unable to go inside the model and to ask what happens actually. We got some best effort ways, but we are more or less victims of the answers. Text as an input, text as an output, and then we try to survive and to make tools from that. And when we're working with these tools, we no longer have an intellectual method, an algorithm. No, we have data. And this data is how we define the problem, meaning that the behavior of a large language model is directly linked to the huge mass of data we are using to train it. And so this data is very important to understand the model. In any data set, we'll have biases. A bias is like a fake link between the input and the output. And any bias in the data set will cause some problems, very, very big problems, because it will give some illusions of good functioning. It will give hallucinations. We all saw this problem. We asked something at LLM, and we got a very concrete answer, like, okay, I'm sure this is the answer, and it's perfectly wrong. And this subject is still a very active academic research topic. If you want, it's not our goal today to detail all the flaws of large language model, which are still very good tools, but well, we have to be careful about these flaws. If you want to have a good insight in all these flaws, we really recommend to read this paper on the dangers of stochastic parrots, and the stochastic parrot definition is a great way of qualifying a large language model. Can language models be too big? The answer, you guess it, is yes. This paper is very important to understand the limits, and these limits are why a lot of application, retrieval augmented generation, code development with LLM, well, they are not so easy subject as we could think seeing the actual field. And well, we are talking about large language model, but now let's talk about open source. The open source movement is a very important technical movement, and there is a definition of what open source can be from the OSI. It's a quick list, but it's important to start from this. It must allow free redistribution. It must include source code. It must allow derived code and modification or patches. No discriminations against people, against groups of people. No discrimination against use. You can do whatever you want with open source code base. Licenses must not automatically mutate themselves. License must be generic. It must not be viral, and it must be technology neutral. All these points make sense when we are talking about software. But, and that's a very, very important point here, we are not actually talking a lot about softwares when we are talking about large language models. And this is where the fun happens. Perhaps I've got a weird definition of what fun is. Today, we see a lot of providers of large language model talking about open source models. And well, it's reassuring. Why? Because open source, it gives us strong guarantees of security, of reproduction. We can reproduce a result of stability. I mean, it's an efficient choice. And it also has a legal meaning. I mean, I got some security when I'm using a source code. But this is a software world, talking about source code. When we are talking about a large language model, what does it mean? We have a lot of different things. First, yes, we got source code. We got training source. We got inference source. But we already know that these sources, even if they can be very important, are not the most important thing to understand and to have some trust toward LLM model, toward this tool. So where is the data? Where are the data sets? I mean, if I don't have knowledge about the data used, I cannot have a way to predict, okay, we may have this or this problem, and we can iterate on quality doing this. No, I'm useless. The data is the most important asset in any artificial intelligence project. And here, this definition does not talk about data. They are the weights, you know, the results. I'm training a model, and at the end, I've got weights. So numerical values that somewhat codify the behavior of a model with its architecture. And these weights, well, we can download them, but what is their value? It's an important question because weights are more or less useless. I mean, I need the weights to make it work, but the weights is by definition what I cannot understand in a model. And there is a method. We are talking about recent academic work. So I need a paper explaining the architectural choices with perhaps some ablation, but we have to be careful, and we need a lot of knowledge to have security using the model. And last but not least, we need documentation. Do we have a clear information about how it works? And if you are a large language model user, you already know the feeling. You want to do something, but you have no way to know if it's going to work if you don't test it, if you don't try it by yourself. And usually, well, you are surprised. We are surprised. So what we see is that talking about the source is a way to ignore the most important parts of an LLM tool, an LLM project. And that's why between some public communications, you got some excerpts from the Llama 2, Llama 3 papers. Meta tells us This is the next generation of open source large language model. But even Falcon or Mistral or Stability AI, everybody actually, when they give us for free, or more or less for free, a model, well, they call it open source. And perhaps it's a bit quick. And you got a table that I'm going to go into details because it's one of the important parts of this webinar. There is a table here that asks a lot more questions, and well, the answers are not so great. We can have a quick look first. We're talking about availability, open code, LLM data, LLM weights, RL data. There is a first training when I do a large language model, non-supervised learning, and then there is reinforcement learning, with human feedback. And it's a very important part of the training. I mean, the Instruct GPT paper was a milestone because it really changed the quality of what we had at the end of the training. And the license. About documentation, we are talking about code, yes, architecture, preprint, paper, model card, datasheet. And then there is the access part. Let's give credits where it's due. If you want to see the whole thing, please go and read this great paper, Rethinking Open Source Generative AI, Open Washing and the EU AI Act, which is a very deep analysis of the situation. What I give you now is just a quick summary. So here they take two different projects. Bloom's, let's be honest, we don't want to work with it out of the box. It's not the best LLM here. And the Llama 2 chat model, and everybody wants to say by instinct, okay, it should be open source. What are the questions we ask in the availability theme? First, open code. Well, for Llama, I don't have the training code, I don't have the fine-tuning code, and the inference code, I could argue that I have just a small version, but perhaps not everything. So even starting with the code, I'm missing some very crucial information. About the data, well, we have only, you can have a look at the sentence from the paper. This is from the Llama 2 paper, a new mix of data from publicly available sources. Which one? No idea. Which does not include data from Meta's products or services. Let's be clear, this sentence is not a sentence from technical people, scientific people. This sentence is from the legal department. And so for us engineers, we need information to be able to say, okay, this model should work for this subject. It's just a complete failure. About the weights. Well, yes, I can access the weights, but there is a very specific binding agreement. And well, every legal department know that it kinds of new agreement, as long as you don't have one or two trials with what we call a jurisprudence. Sorry for the French word, but I'm missing the translation. Well, you don't know how it will work out. And even the license, well, is not actually an open source one. Well, there is a limit which is a very broad one on the numbers of users, but we could argue that it's still open source. The most important point here is the absence of information on the data. Second part is about the documentation. Well, we got a huge information deficit. The papers, let's put it that way. One of our work in Datalchemy is to read a lot of papers. We are paid by some clients to read papers and to give feedback with which one should be interesting. So we read a lot of papers, and this kind of papers from the Llama 2, I see them more as marketing documents. And it's not because I don't like Meta, it's because there is a huge lack of information. I mean, what specific architecture choices were made? Is there some ablations? I don't know. The use of data sets is a joke. How the reinforcement learning was used to do a fine-tuning, what kind of betterment we had of different metrics and different data sets, I don't know. Ablation studies obviously do not exist, etc., etc., etc. It's a bit sad because this model, the Llama 2 model, was created because a lot of researchers gave this kind of information, but well, this is what it is. So yeah, about the preprint, about the architecture data, about the paper, no, we don't have actual information. And about access and licenses, well, we could hope to have a package, I mean, just a pip install. It doesn't, but well, we have a Hugging Face, we have some good work, and the API is subject to some specific conditions. Two more slides, and then I will leave the stage, the virtual stage, to Toprak. Why is this important? Because we could argue that it's a philosophical, a cultural debate. It could be. I mean, open source is somewhat of a society project. Why not? It's not our goal here. Here, we want to talk about efficiency. And not talking about the cultural importance of open source, I still want to use open source because, well, I can work and I can trust in the future. Why? Because if I work with what I would call a closed tool, I'm at the mercy of the slightest problem from the provider. I mean, the supplier, the provider could not address a bug. It could change its pricing. It could have a new strategy. It could choose a new way of using the tool. And if I got a dependence to this supplier, I will have a problem. However, when I have an open source tool, when whatever happens, I got the source code. I can legally reuse it. I can debug it. I can fix it. I can fork it. So there is an efficiency argument, which is very, very important. We are talking about reversibility, not being too much dependent upon a supplier. And this problem we have in the software world is 1,000 times more explosive with large language model. I mean, it's not just that we cannot, better the work or have some legal guarantees. I mean, we are blind. We are blind to a lot of problems. There are biases. I mean, data sets used for large language model are so big that there are some biases. The stochastic powered paper found some. And let's remember that the Falcon paper only did some data quality to have a better model than Llama 2 when they did it. So, well, this is a huge problem, and we are becoming very dependent on suppliers. I mean, today there are a lot of use cases where, well, we got a model which at one time is working, but will the next model still be working for our current problem? We don't know. And it's another subject, not an engineering problem, more a strategic problem. There are some custom licenses, and as long as they have not been tested by the cards, there is a risk. So that's why it's still an important subject, and even if we are not going to offer you a wonderful solution, because I'm not sure there is one, we got to be conscious of these problems. There are some legal implications. There is a lot of talk, a lot of ink on the AI Act, a very important text. There are some huge guarantees which are good from a citizen point of view in the AI Act, but there is something a bit tricky that the authors of the paper we are using for this webinar detected. There is an exception for AI models, large language model, about the open source definition. They have to be open, but the definition, the legal definition of what is an open large language model has been postponed. So yeah, we want some open source large language model, but today we don't know what it means. Okay, it should be subject to exception as regards the transparency related requirements. And all this, well, sorry. And AI model suppliers are exempted from drop and keep up to date the technical documentation of the model. I want to cite this sentence because it's very important, including its training and testing process and the results of its evaluation, which shall contain, etc., etc. So there was a lot of lobbying in the European Commission, and I'm not here to give you my personal opinions, but from, let's say, citizen point of view, it's a loss, because the open source world will legally mean nothing in Europe. Toprak, I suggest you take the lead and you tell me when you want me to switch the slide, or perhaps you want to share your screen as you want.
No, thank you. It's cool. I can tell you.
Okay.
Thanks, Eric, for the dive deep, for the open source LLMs. So now I would like to talk about more the commercial or practical part. So for starting, I would like to talk about the license types. I don't know for you, Eric, or for others. For me, when I see any new LLM, I first check the license, then I become happy or not. So as you see, if the license is Apache 2 or MIT, it's cool. You can use for commercial purposes. But for MIT, there are some extra protection for the patent. For Llama 3.3, the version can change, depends on the model version. So it's okay, it's commercial too, but as Eric mentioned, if you have more than 700 million monthly users, you need to grant a specific license from Meta, otherwise you're going to be penalized. But honestly, I don't know the definition of user. Is identical or just single user for each call. For Gemma, it's similar to Apache 2.0, but there are some additional restrictions. But as I see the license description, no problem for the commercial purposes. So the last two, the things don't make me happy when I see any release. The first one is CC, BY, and C. So this is non-commercial use only. So in order to give an example, some models for like some models for QN, not too much, and the models from Cohere, if I'm not wrong, they are mainly for non-commercial purposes. And the last one is generated by Mistral, which is called Mistral AI Research License. It's non-commercial as well. It's mainly for research and test. But the good part is sometimes they share some models, first MRL license, then they switch to the Apache 2 license. So if you're lucky a bit and if the model is still good, it can be an option. So can you move to other slide, please? So I would like to talk about how we choose the open source LLMs for our cases. So I would like to mention the public leaderboards. If we talk about the open source LLMs, we must talk about the Hugging Face to download or like see everything about the models. The first thing is the Open LLM leaderboard, which is a good leaderboard where you can see almost all the LLMs, and there are many filters such as like number of parameters, like quantization, and also you can choose the model is from official provider or not, which means that you can separate or filter out the fine-tuned or not fine-tuned models. And the second one is personally, I'm really involved for 3-4 months. This is for mainly embedding models, so which is more retrieval problems on the LLMs. So what is cool there, you can choose different problems and you can choose different languages. For our case, we always check the retrieval and re-ranking. Plus, you can see the comparison on the French language. The second one is, I think, the most popular one on the world is Chatbot Arena. The difference from the Hugging Face one is you can compare the closed, the enterprise models as well. But the drawback from my perspective, if any new model is coming and if they don't want to show it as soon as possible, for the case of QN 2.5, they don't put it. And the good part of this website, people are voting for different stuff and they can see the results. So the last one is Local Llama. It's a subreddit from Reddit. So there are many good comparisons for the model releases, model benchmarkings, etc. This is a thing we also use. The second one is the model specialization, I would say. So as you know, there are many models and all the models are not good for all the tasks. For example, for our cases, we always check the model is good for French and English. The last one was Phi4, I would say. I was really surprised for the performance. Even the model size is not super complex. But when I checked, the dataset is majorly English. I said, okay, it can be cool for other tasks, but for us, not too much. And same for coding or the domain-specific tasks. For example, you can find some fine-tuned models that are mainly trained or fine-tuned on the health data if you have any problem on the health applications. And the third one is the validation of the reliability. So as you know, models are always sharing, the companies are always sharing the evaluation data on the global benchmarks. But I'm pretty sure everyone is sure that no one can guarantee this benchmark dataset is not used during the training. Even if it's used, but performance is not like 100% now. So our personal opinion is that find some people who use these models or they are like validated by the users, then we can use it. And the last one is, I think I will talk a lot. Instead of using big models, we always use small models on specific tasks. For example, if we need this easy translation task, use small Mistral model. If we need to use like agentic approach to separate the tasks into similar tasks, use very small model from QN or Llama to just classify the task, etc., etc. It can improve the performance. It can definitely improve the inference time, and it will be cheaper. So the next page, please. So now I would like to talk about the pros and the cons of the open source LLMs. The first thing is the Eric mentioned a lot, the transparency and the stability. But in this case, I would like to say like open source for the best case. And if you host these models on your servers or any private server. So first one is the transparency and stability. So if we want to use the open source model, we just download the model, we do the inference, and no one can change the source code, I mean the weights. The other part is the stability, but I think it's a bit outdated now. You can correct me because I'm not good at the closed models such as OpenAI API, etc. Because there was a paper in April 2023. They just made a study on GPT 3.5 and GPT-4. They just observed the changes of the model response. But as far as I know, when they provide an API now, they provide like release date. And in my personal opinion, I have no idea again, they are using stable models and they change it. When they change it, they just change the version. So probably this problem is a bit outdated. The second one is privacy. So for our cases, this is the first if and else when we want to use LLM, especially if you want to collect a personal data and if you want to use it for text generation. And if the API is working outside of EU, you must ask to the clients, okay, your person's data is going out of EU. Otherwise, you can be penalized too much. So the privacy is like if and else more than a feature. The third one is the flexibility. The variety of the closed models are not too much. For the open source models, the model size can start from 500 million, maybe less than it as well, until 300, 400 billion parameters. So you can also find different tasks for different parameters as well. And the thing Eric mentioned a lot, you can just avoid the dependency on the providers. Okay, there's a dependency as well. If you have some GPUs on your servers, okay, not too much dependency, but if you have some dependency on your cloud provider, there will be some dependencies, definitely. And the fourth one is the cost. If you want to implement a small scale chat application for your company, it means like internally, so you can handle this job very easily without any privacy issue and like transparency issue. So this is a thing we also do. The cost can be lower. And the last one is, this is the thing we try to do now, and this is one of the important stuff. Open source community. I mean, it's everywhere, even in Paris, there's a huge community for open source LLMs. So you can see many documentation, many experiments, many lessons learned from the open source model, and you can also pay back to this community. But honestly, the using open source models do not have only positive sides. There are also some drawbacks. The first one is installation of the infrastructure for the first time. I mean, it's not like only deploying an application to the servers. So in order to implement an infrastructure that works with the GPUs, we need some technical knowledge, or we should have some consultancy from the companies to have the initial setup and the maintenance, as you guess. And the second one is, I think, the most difficult part, the scalability. Imagine if you have an application that has 1,000 requests every second. So there should be like a trade-off between using closed models and open source models, except the privacy concerns, I would say, because the cost can be really huge if we need to host more than 1,000 GPUs. So it should be discussed, or it should be done very well. And the last one is the guardrails. I want to mention as well, because as far as I know, if we use open source models in our servers, we are responsible for the security. So which means the alignment of the answer. So there should not be any issue for like ethical racism, etc., etc. So this is the reason we also use some security models for the text generation. So the next slide, please. So what are the lessons we learned from the open source LLMs I wanted to mention? The first thing is having an evaluation data set. I'm pretty sure many of people here that for software, the test is indispensable. So there's no way to avoid the tests. So we always have evaluation data set for some false positives, for some quality checks, and for some code questions. So we generate some of them ourselves, and we also have them from the continuous feedback from the users, and it helps a lot. Sometimes we like the answer quality a lot, but when we run this evaluation set on the new model, we see that sometimes model does not generate good answers for our cases, especially for the campaign management. And the second one is the same again, divide and conquer. Instead of using many big models, more than like 70, 80 billion parameters, use small models for different tasks, then make a pipeline. I'm pretty sure you also observe that if you inject more than 50, 60 instructions, a single prompt, the model will avoid many of them. So instead of it, just have some shorter prompts that includes 10, 15 instructions, then get answers and iterate one by one. We saw that it improves the performance if you compare like using a single complex model or smaller model iteratively. You can give it a try as well. And the fourth one is, it was a bit funny experiment for us. As you know, if you want to host the LLMs, you need to serve these models using the frameworks that can be VLLM, SGLang, the Hugging Face library, or Llama CPP, mainly for the local model, local runs. So what we do, if we use small models, we use Llama CPP, then we move to the server, which can be VLLM or SGLang for our case. So we use QN model, and we were running locally. There was no issue. So we just pushed the deployment, the production, and we just realized, especially for table generation and numerization, it starts like 1 point. For the second one parenthesis, 3 comma, and it changes a lot. I spent like 1 day on it, and I just realized in Llama CPP, the sampling parameter name is repeat penalty, but in Llama VLLM and SGLang is repetition penalty. So since we use too much, it doesn't affect and the performance reduced, and even the syntax error or grammar error, it appears. It was funny, but I mean, we learned especially at least in 1 day. And the last one is, this is the thing we also realize, the false positives from the security models. For 5, 6 months, I mean, since the beginning, we haven't seen any true positive problem for the guardrails. But honestly, we don't have any person who tried to hijack the prompt or the LLM. So sometimes model is just blocking the question. It says, I can't answer this question. So what we involved to evaluation dataset now, we put some false positive questions, which means that there's no error. But for example, for SQL question, you just say, can you please refactor my SQL query? There are some age columns. Since the age is less than 15, 16, the security model says that there's child abuse. I know, I'm sorry for using it, but the model is Llama Guard 7B. So it's an official model from Meta. So we solved this problem. Now we fixed with prompt, and we are going to deploy it probably in this week. So this is one of the things you can give it a try when you want to change the security models that can help you. And I think it was the last slide for me, Eric. Yeah, so the microphone is yours.
Thank you a lot. So as a conclusion, and after that, we got more or less 10 minutes for any question you would like to ask. So can we use, and let's say now, a pseudo open source LLM? Well, Toprak gave a lot of very great insights. I can only agree with divide and conquer. You want to minimize the complexity. And okay, we got black boxes. Let's have the smaller possible black boxes. Great. But let's be honest right now, if we want to do some advanced treatments, even simple one, a good model like a Llama, like a Mistral, will always be better than some true open source like Bloom model. And the vast majority of these tools won't be actually open source. And I think we can be honest with ourselves, they will never be. So it's more be conscious of the risks that let's go and have open source models. The most important, Toprak said is, and it's a very important factor. For example, we're working for Council of Europe, where some data cannot go outside of Europe. That's all. So when we handle them, we must be careful. We know there will be bias. Well, let's test it. Let's test it a lot. We don't want to jump on the latest model. No. The latest model is not the best one. It's not true. We had some use cases. I remember one use case where in Llama 2, everything was good. Llama 3 went out. We were like, okay, let's test it. It will be better. And it was actually far worse. So, okay, this is the field we're working on. However, as a conclusion, perhaps we can take a step back and see that it's not only the large language model where we got this problem. Since the last 2 years, for a lot of projects, for a lot of people, AI is large language model. It's not the truth. There are a lot of other fields, from point cloud detection, robotics, reinforcement learning, computer vision, audio processing. I mean, there are a lot of fields. And something that happens in nearly all fields is that the big player, the big providers, do not want to give us the dataset information or the datasets. First example, only the old people. The old people are people who were doing deep learning before ChatGPT. Vision transformer. We are in 2021. Google throws out a new paper. An image is worth 16 by 16 patches, more or less. And it's a huge paper. Why? Because the transformer architecture, we all know the transformer architecture that right now is the basis for any large language model, even if some Mamba is starting to appear. Well, at least was used for computer vision. And it was important. Why? Because, well, the same tool for different fields, it was very interesting for researchers. For engineers, it was a more complicated, not black and white answer, but I won't go in this direction. So they gave us a model, and they showed us great results on a very specific dataset, the GFT300M dataset. It's an incredible dataset. You got 300 billion pictures with a lot of different categories. If you don't start working for Google, you will never see, I will never see, I won't be starting for Google, this dataset. And actually, the big players are giving us their models, their architectures, because, well, it's not where the actual value is. We will never see their dataset, because dataset is a true investment. It's where you can put money. It's where you will have more money in return. So there are two things there. First, the big players want to protect themselves from legal consequences. If they give too much information on the dataset, people will find biases, and it could become a legal liability. Okay, but there is two kind of an investment. And this data, it's the most important thing we would need to understand these models. And I give you this example from the transformer. It happened to Google again in robotics. If you do a bit of robotics, you cannot have missed the RT1, RT2. It's an approach where the model is trained of a lot of different data, and it learns to map pictures, video stream in input to the motor control as an output. Well, the data set is not on internet. It will never be. So the main conclusion here is nothing new happened. I mean, it's the case. It has been the case since 2014, 2012. However, well, let's be very careful with this open source world, because, and we see it a lot, some people who are more management people, strategy people, I mean, they hear open source and they are going to be trusty. They are going to say, okay, let's go there. And we, Datalchemy, but you perhaps in different levels, need to be the one who says, careful, open source here does not mean what we think it would mean. This being said, I really hope it was interesting. If you got any question, please feel free to ask them.
It's actually a question a little bit general, I think, addressed to both of you. I'm going to play a little bit the devil's advocate here, but it's open. I think that LLMs should somehow not really be compared to open source frameworks like Git, or I don't know, or Kubernetes or something where it's really maintained by a community. I think that LLM should be compared somehow to algorithms. Like, for example, you have the famous company Dolby Lab, which sells algorithms pure. I mean, they just license this. They don't sell hardware. They sell algorithms, which then you find everywhere in all the earplugs, the soundbars, and everything. And that's the business model of Dolby. They develop algorithms and then they sell them under a license. I think that somehow that's what would be the closest in the LLM business to that. And if we do this comparison, I would somehow understand why it's not open source. It's a problem because then we have black boxes and we need them for we need to fine tune them for our thing. But then the question is there a way somehow to transpose what companies like Dolby do to the LLM business? And second of all, if these companies like OpenAI, for example, they just open everything, the question is, OpenAI is already not making money today, not enough money. It's not even by doing that, they're losing money. The question is, how would they manage to still make money if they open source everything? There's probably a way, I don't know. And the risk is, if we impose them to do that, is there a risk that they stop developing LLMs and improving them? And that's it. It's a very large question, actually.
Toprak, please be my guest to start. I will be happy, or as you want.
I can answer the second question personally. I think it's a very good question because there's a trade-off between the commercial side and the research side. So because you need to sell something which cannot be done by anyone. So personally, I don't know the question, but my personal question and my personal answer can be that there can be some quality checks, but it's like law, like ethical purpose, etc. Because you cannot provide your algorithm. I don't know. This is my perception. Even if you have like, if you provide the algorithm like the models Llama 4 or 5, maybe you don't have this environment to do, but there will be some people who can train this model from scratch. So it's an interesting question, and I think there is no open answer. It should be answered by business people as well. So there can be some quality checks, like restrictions, if the model pass this stuff, so it should be done. But another thing, just I'm thinking as a bad guy, okay, for the quality checks, answer like this, otherwise answer like this. So personally, okay. I don't have an answer for it.
Well, I will bounce with my personal answer. Well, yeah, I understand that money people want to make money. It's how the world goes around. And well, I don't have no superpower to change the world. I deeply regret it. But well, it's the case. If you are selling any superpower, obviously, please contact me. But that won't be my answer. I understand the commercial approach of whatever, Meta, Google, they need to make money at one time. And you said it's OpenAI is not making money because there is a huge compute cost and a huge blindness. And it's not like they say, okay, we burn 100 more million of compute and we will have the new model. They don't even know. So this is the problem. So not as a citizen, but as an engineer, I would like first for them to stop calling that open source. It's a bit ridiculous, but this world has nothing to do here, let's be honest, and it's just confusion. And I would like to have some, at least, true guarantees. I mean, some test on the data. They can avoid to give us the data, but tell us, okay, here are all the statistical analysis we did on the data. And it would be far more useful for me. And I would be like, okay, I got this new subject. Let's have a look at the analysis and be informed if I can do it or not. This at least would be great. I understand that it would create some legal liability, but well, at the same time, you're selling something, perhaps you can accept some legal liability. And to answer more, well, I think the answer is that if we want at one time, and I'm going to once again become a citizen, I'm sorry, but what makes some great open source projects very good is because it's a community effort. I mean, you take the Linux kernels, you got a lot of people who a lot of times are not even paid for doing what they do. And why does it work so well? Let's be clear, because they want it to work well. And right now, well, there is a compute price, which makes it difficult. Perhaps this field is very novel too, but I would dream to have a public initiative where people can jointly work on a data set representing things. And it would perhaps give something more interesting. Obviously, we cannot wait for the commercial players to give us what they are paying money. So I hope we answered properly.
Okay, thanks. I agree with the fact that they should just stop calling it open source. It's not open source at all, and it's not even developed in the open source sense. Like Linux is maintained by a community. There is no community behind OpenAI or even the Llama models. You just take it and use it. It's not something maintained. I agree with that. Maybe for the quality check, I don't know how it's done for companies like Dolby when they sell licenses. Do you have any idea how they do? Because I guess that when, for example, Sony wants to integrate the Dolby Atmos technology in their earplugs, they somehow want to check the quality because they don't just take the Dolby Atmos black box as a like this. They want to make sure that that black box works. And maybe we could, I don't know how is that model, maybe we can transpose that to the LLM world to make sure that OpenAI just doesn't sell us a piece of shit that we don't know when it will fail.
Yeah, I think I don't know a lot about Dolby, so I don't want to say some wrong things. But I think there is some model to be found, and there is some quality guarantees to create, whatever the means.
But the problem is that the problem on the LLMs are more non-deterministic. So it can fail once in 1 million try. So difficult problem.
I agree.
We got dear Toprak a question. What do we think about thinking models like O1 or O3, which can have inference time to simplify complex engineering work step by step?
Ashish, thank you for the question. Honestly, I never experiment on the preview models, I mean the thinking models. But as far as I know, the complexity of the models on the GPT, except O1 GPT or Mini, because on the latest paper of Microsoft, they said they claimed 8 billion parameters. But I don't know, it's not coming from OpenAI. The model size is still big. But the good part from the users of LLMs, what I see, the companies like Meta, QN, Cohere, they can cache the performance of the ChatGPT models. And if you see the evaluation criteria, and I don't say that evaluation is the only criteria, they can catch the closed models. And this is quite expensive for the OpenAI part as well, consuming the complex LLMs. So they must go back to the simpler models than the complex models. But for the preview models, I'm not sure they divide into the tasks like one by one, because as far as I know, they use these like thinking tokens for costs too. So personally, I don't know how they work very well, but they need to go back to the simple models for them to serve their services cheaper and consume less energy. They must do it.
I will bounce on the answers if you allow me, Toprak.
Yeah, please.
I played just a bit with them, and please be informed. I'm biased. I'm an old school engineer. I prefer 10 small models. I can test any one of them. I can replace any one of them with a better version than that a huge, not very clear thing with some thinking token I pay for, and I'm not sure to understand what is public relations and what is actual science in the answer, and I'm talking about control, I don't control properly. It's always a problem between, you do a proof of concept. Hey, look, it can work. Yeah, yay. And then you want an industrialized product. So, hey, we want it to work better on this use case. When you got a big service like O1 or 3, where you can try prompt engineering, which I see as kind of a mental illness sometimes, meaning that, yeah, you can better things, but you don't know what you're doing actually. And if it's your only option, well, you can be sad. And I prefer to have smaller models, and even in the architecture, it's simpler as long as you are using some clever things like Kubernetes, whatever. It's better because if you got one failure, you can perhaps have a low-level service, but still something running. All these engineering reasons to prefer multiple smaller models.
I think this is the same mentality for the microservices as well. I mean, instead of having a single big service, division into the smaller services. If there's any issue, just fix this service. So definitely agree with you. I hope it is the answer for you, Ashish.
You're welcome. If there is any other question, please feel free to ask. Please know that you can still send us questions by LinkedIn or whatever social media. You will find us and we'll be happy to talk with you. And the next webinar from Datalchemy will be next month, and we'll be digging into science, really a big dig, but a very interesting one, into causality, which may be a bit of a provocation. Can I do causal reasoning with the models? But statistical causality learning has been a thing since 2021. Hinton worked on it, and we had during the last NeurIPS, which is a big conference in deep learning, a workshop on causality with a lot of very interesting papers. So it will be the occasion to dig a bit into these papers. I hope you enjoyed it. Please feel free to make any critiques. We'll be happy to have your feedback.
I think no other question. So thank you so much, Eric. I want to conclude as well for giving us this opportunity. So I believe we will do some in the following months. And thanks again for all.
You're welcome. Wishing you, every one of you, a great day, success, and superpowers if you can find them.